yesterday we graphed expressions that had a constant at the top and an expression at the bottom, or two expressions on the top in the numerator and denominator, but no power higher than 1, right? It was always like x plus 2 over x minus 3 or something like that. Well, today we're going to deal with expressions that have a higher power than 1, okay, like an x squared or an x in the expressions, okay? So all of them are in the form ax to the n, so it could be 2, could be 3, could be 4, we don't know, plus bx plus c over dxn, again, could be 2, 3, 4, 5, plus ex plus f, okay? So they're like, they're polynomial expressions, basically, okay? The vertical asymptote is always where just like it was yesterday, it's where the denominator equals 0. So you're going to set that equal to 0, okay? And in a polynomial, like a quadratic, how many zeros do we get then? 2, right? You have to factor it and figure out where the 2 equals 0. So we're going to have more than one vertical asymptote, okay? Now, the horizontal asymptote is a little tricky. There's going to be 3 rules, so you might want to just like kind of, as we go, write those rules together. The first one is when this exponent is less than n, this exponent down here, okay? If that's true, if the power in the top one is lower than the power in the denominator, then our asymptote is 0, okay? So for this one, this is 6x to the what? Nope, not first. If it's not there, it's 0, okay? So this is technically 6x to the 0. So the m is less than the n. Does everybody see where I got that? The m and the n? We'll get through all 2 cases when they're equal and when m is greater. But let's stick with less than for right now. All right. So because the exponent is smaller on the numerator than it is on the denominator, that means that my horizontal asymptote is 0. Okay. So I got to solve my vertical asymptote. X squared plus 3 is equal to 0. Plus or minus the square root of 3. How would I solve this? What would you do first? Subtract 3. So I get x squared is equal to negative 3. Is that possible? No. So this one doesn't have a vertical asymptote. Okay? It only has a horizontal asymptote at 0. Okay? So I've got this horizontal asymptote at 0. All right? Now, I'm going to plug this in my calculator. Oops. I'm going to take that all the way out. There we go. I'm going to plug this in my calculator. 6 over, it's going to be in the way, 6 divided by x squared plus 3, close parenthesis, right? Oops, I divided by, this is missing. This isn't going to, I need to move this. this again. 6 divided by x squared plus 3. All right, so let's see what that looks like. Okay. Does it have a 0 as an asymptote? Yeah, right here. Right? It's both ends are getting close to 0 but never crossing, but it doesn't have a vertical asymptote, right? So instead of being a hyperbola, it's this little like bumpy curve thing. Okay? So to figure out how to graph that, I'm going to go to the table, pick some points. Okay, so like -1 is at 1.5. That's about there. 0 is at 2. Oops. 2 is at, or 1 is at 1.5. 2 is at 8.5. Okay, so my curve looks like that. I'm sorry? Yeah, for some reason that one of those looks just... All right, so does that make sense? So when there is no vertical asymptote and the y-intercept is 0, you're going to get this little bumpy looking curve. Okay, because it's not split, so it doesn't make a hyperbola. Okay, what's the domain of that function? All real numbers, right? X can be anything. How about range? Y, everything. Yeah, it's between 0 and 2, right? Because it's not going to get above 2 and it's not going to get below 0. So y is got to be less than or equal to 2 because it can actually be 2. And then it's got to be greater than 0. So that domain is a little bit tricky. Okay? And then there are no vertical asymptotes, and the horizontal asymptote is y equals 0. Okay, so a little bit trickier. Are we okay with that?
Why are there no verticals again?
All right, let's move on where the m and the n equal each other. So we've got a squared and a square. Okay? So when m equals n, then the vertical or the horizontal asymptote is a divided by d. Just like yesterday, remember we did a divided by c? Okay? So when these two are equal, and weren't they equal yesterday because they both had a power of 1? So we were kind of already learned this rule. When they're equal, then the horizontal asymptote is just whatever that fraction happens to be, a divided by d. Okay? And again, the vertical asymptote is where the bottom of the fraction equals 0. Okay? And one other quick thing I want to mention, the x-intercepts, because we didn't have the x-intercepts in the one up above this, but the x-intercepts are where the top equals 0, the numerator equals 0. So what are going to be the x-intercepts for this one? When does x squared equal 0? Oh, come on, guys. When does x squared equal 0? No, that would be 1. That's the only way that x squared could be 0. If x is 0. Yeah. Right? So this is going to have an x-intercept, because remember, zeros are where the expression equals 0. So the x-intercepts are going to be where the numerator equals 0. So in this case, we're going to have one x-intercept at 0. Okay? All right, so we got to find the vertical asymptote. So I'm going to set x squared minus 4 equal to 0. Okay? add 4 to both sides, x squared equals 4, take the square root, and I get x is equal to plus or minus 2, right? Okay, so my vertical asymptotes, I should have done all this in green. My vertical asymptotes are going to be at positive 2 and negative 2. Positive 2, negative 2. Okay? My horizontal asymptote, when they're equal, is going to be negative 1 over 1, which is negative 1, right? So my horizontal asymptote is going to be there. Okay? Now let's see what that looks like on the graph. So I go to y equals and it's negative x squared divided by x squared minus 4. Okay? Let's see what that graph looks like. Okay? So I've got my horizontal asymptote here at 1. I've got my two verticals at 2 and negative 2. All right? So my graph and remember we said it intersects the x-axis at 0. So my parabola is going to touch the x-axis at that one spot. Okay, the horizontal asymptote is just whatever the coefficient here is divided by that coefficient. So this coefficient is negative 1, this coefficient is 1, so negative 1 over 1 is negative 1. Okay? All right. Okay, how about domain and range? What's the domain of that expression? No, not quite. Remember, it can't. Those vertical asymptotes mess things up. So it's going to be almost all real numbers, but what two numbers can't I use? Right, positive 2 and negative 2. So it's going to be all reals except positive and negative 2. And how about the range? A little bit trickier. Where is the range limited to? Let's look at the y's. I'm good going this way, right? So far so good on all the y's, all the y's, all the y's. But how about when I hit that? 0. And then it kind of stops, right? All the way down to negative 1. And then it starts again. So how would I describe that as a range? Jordan, how would you describe that as a range? Okay, and then our final expression is when the m, the leading coefficient at the top, is larger than the leading coefficient at the bottom. And when that's true, it has no horizontal asymptote. Okay? But the vertical asymptote is still going to be the same. You're going to get it by setting the denominator equal to 0. So my vertical asymptote is at negative 2. Okay? So I plug it in at negative 2. And no. All right, so let's look at what that graph looks like. So I'm going to do x squared minus 2x plus 1 divided by x plus 2. Graph it. Oh, I didn't set the